Okay, let's do these two problems in section 3.3, 20 and 22. Several people had trouble with them. So I'm going to do this by using what we know about graphing. Now, we know the book does it differently, but I like this method. X minus 5 means it has to go through plus 5 because that's a 0. And x plus 1 squared means it has to bounce off of negative 1. Now, this is going to be a degree 1, 2, 3. So one end's up and the other end's opposite it. And since it's going to be plus x squared, x cubed on this, it must be coming from down here. And then if it bounces at 1, it bounces and then goes up through 5. So that's what this would look like if we were graphing this as a function. So when are the y values, for what x's are the y values of this greater than 0? Well, all the y values here are less than 0, and so are these. It's equal to 0 there, but we don't want to be equal. The only place where they're greater than 0 is from 5 on. So the solution to this would be the set whose elements are numbers such that the numbers are greater than 5. Or in interval notation, 5, not including it, to infinity. Okay? All right, now let's do 22. 22 is also a third degree. It is also positive x cubed. So it's got to start down, go up, and could curve and go back up. This one has zeros at 4, has a 0 at negative 3, and it has a 0 at negative 6. So if it comes from below up, it must, and it's a single root, so it's got to go straight through negative 6, come straight through negative 3, and go straight through 4. So when is this graph, when are the y values of this less than 0? Well, all the y values are below 0 for x's from negative infinity up to negative 6, negative infinity up to negative 6, the y values are less than 0. At negative 6, it's equal to 0, so we don't want to count that. And then from negative 3, these are all negative y values, all the way up to 4. And after that, this function goes off to positive infinity, so all the y values are positive there. So this would be the solution to that. Okay?